Before delving into the species of exoplanets, it's crucial to understand the challenge scientists face in discovering them. The primary hurdles are the immense distance from the Earth and the overwhelming brightness of stars. The nearest star to the Earth is our Sun, and it is approximately 150 million kilometers away. The second closest star, Proxima Centauri, is over 4.24 light years away, or 9.44 trillion kilometers. The brightness of these stars is so intense that it makes it difficult to observe anything else in their vicinity. To illustrate, if we try to spot a firefly twinkling around cricket stadium lights from a considerable distance, it is comparable to attempting to observe an exoplanet from Earth. Hence, until 30 years ago, know about these exoplanets, as their discovery was a monumental challenge. The journey to unveil the secrets of these distant worlds continues, opening new chapter in our exploration of the cosmos. What in the famous scientist Stephen Hawking's words, humanity can transcend its ephemeral limits with the help of both the mind and machines. Following his insight, some scientists embarked on a new journey of exoplanets, diving into the captivating light emanating from these beautiful stars. Consequently, a revolutionary method for the exoplanet discovery emerged, known as Doppler spectroscopy or radial velocity method. Doppler spectroscopy or radial velocity method challenges the common misconception that the Sun is stationary and all planets orbit around it. The reality is that our Sun, influenced by the gravitational effects of massive planets in our solar systems, also orbits around a common center, albeit in a tiny orbit. This motion is challenging to precise due to the vast distance involved. Through observations conducted at the Arecibo Observatory, the movement of our Sun influenced by the gravitational pull of Jupiter was measured. The Sun at the speed of 13 meters per second due to the Jupiter's gravity and 9 centimeters per second due to the Earth's gravity is in orbit within a small region around the center point. Similarly, thousands of light years away, the stars in distant galaxies experience fluctuations in their motions caused by a gravitational attraction of their massive planets. This phenomenon is known as radial velocity, where stars also exhibit motion due to their planets. This radial velocity is easily detected through the Doppler effect. Understanding the Doppler effect might require delving into intermediate level subject involving formulas and mathematical calculations. However, to put it simply, it allows us to determine the radial velocity and consequently the frequency of any starlights. Let's illustrate this with an example. Often, when a train is crossing platform, the sound of its horn suddenly changes. This occurs because as the train approaches, the frequency of the horn increases, and as it moves away, the frequency decreases. Similarly, in the search of exoplanets, astronomers use Doppler spectroscopy to observe shift in the spectral line or pattern of light from stars related to the order of colors. The Doppler effect enables scientists to discern the radial velocity of stars and consequently the associated with their motion. By applying this method, astronomers have successfully discovered 1075 exoplanets to date. The major limitations of this method was that could only detect planets larger than or equal to Jupiter orbiting very close to their stars. This technique was not effective to finding Earth-like rocky planets in the habitable zone around their stars. To overcome this, scientists developing a new technique known as transit photometry.